In 1 minute, a fly travels at a constant rate from -2, 0, 1 to 4, 8, 25. What is the displacement vector of the fly after 1 minute? Well, it goes from -2, 0, 1 to 4, 8, 25 in 1 minute. So the distance between -2 and 4 is 6 units, right? Yeah. So you're going to draw your little vector thing. You're going to go 6. I'm making a vector. And then the distance between 0 and 8 is 8. Oh. And the distance between 1 and 25 is 24. And that is a vector. How do you erase?
A little eraser on the left above the little target.
There we go. And that is the answer to number 1.
Okay, so for the second one, if you double the vector of 6, 8, 24, you get 12, 16, 48.
Right up there.
Okay. And then if you add 12, 16, 48 to -2, 0, 1, you get the second point, so how far the point it gets to in 2 minutes. And then if you do the distance formula for those 2 points, okay, so the point is 10, 16, 49. And then if you do distance formula, you do 10 plus 2 squared plus 16 minus 0 squared plus 19 minus 1 squared. I don't have any more room.
Where'd your 19 come from? 49 you mean?
That's what I meant, 49. And then
Just put equals at the bottom there.
equals. And then I got 52 after you simplify that. Is how far it went.
Number 3, assuming the fly starting point is the vector of -2, 0, 1, or not the vector, the point. Write an equation in vector component form using the 1 minute vector. Okay. So you have to use the vector component equation, and you have to put it into 3 dimensions. So I did X, Y, and Z to make it 3D. And then I put in the first point. I added T to the vector that you get in number 1, which is 6, 8, and 20. Oh, 6, 8, and 24.
Good job.
Where would the fly be after 8 minutes? So I would just use the equation that Paul came up with.
Or I came up with.
Many of you came up with. And have my starting point. And then instead of, well, what would we substitute for t here? 8. So t is 8 minutes. Multiply that by my 1 minute vector. What was it? 6, 8, 24? Okay. And then we can go ahead and scale that vector out. So the new vector would be 48, 64, 192 is your vector. And then when you add it, your new location is 46, 64, 193. Thank you, Connor.
Yep, anytime.
Okay, so that's answering the question where.
I concur. Okay, In 1 minute, whatever, we already told all that. Write parametric equations to describe the fly's location after t minutes. It's just basically x, y, and z equations in terms of t. So, we're going to take our equation that we used in the previous part, and we're going to go x, that's going to equal -2 plus 6t. That's time. T equals time. Y equals 6 plus 8t. Or is that 0?
That's a 0.
Oops. I actually wrote 6. I was thinking of the 6t. 0 plus 8t. And then,
y equals 18.
sure. Z equals 1 plus 24t.